Okay, as we look at this, it says if 200 grams of water is to be heated from 24 degrees Celsius to 100 degrees Celsius to make a cup of tea, how much heat must be added? The specific heat of water is 4.18 joules per gram degrees Celsius. So, in your notes somewhere, you should have the specific heat equation of Q is equal to Cp times the mass times the change in temperature. This is something like what you were doing on the lab that you just turned in to me. Okay? So we have the specific heat. We want to know how much energy must be added to change it to that particular temperature. So the specific heat of the water is 4.18. The mass of the water is 200 grams. And the delta T, the change in temperature, is final temperature minus initial temperature. So my final temperature is 100. My initial temperature is 24. So in my book, that gives me 76 degrees Celsius. Now, when I multiply these particular numbers together, 4.18 times 200 times 76, I get a value of 63536. Now that has 5 significant figures. I do not need to have 5 sig figs. I see 3, I see 3, I see 4, I see 3. So I'm going to use 3 significant figures. So how am I going to get that into 3 sig figs? I'm going to put 2 placeholders in at the end. Now, what is my label going to be? Well, grams will cancel, degrees Celsius will cancel. That will leave me with joules. Could I then convert that to kilojoules if I were asked to do so? Absolutely. Okay, but I was not asked to do so. So that would be my final answer right here. In order to heat that up, the amount of energy that I'm going to need is 63,500 joules. Here is my next example problem. Go ahead and copy it down, and then we will work this. This particular problem states, what is the specific heat of a substance that absorbs 25,000 joules of heat when a sample of 100 grams of the substance increases temperature from 10 degrees Celsius to 70 degrees Celsius? So, I'm being asked to calculate and find the specific heat. Once again, my equation, specific heat is Cp up here. So I'm going to need to have the Q, which I do have, 2,500 joules. Cp is my unknown. I should have grams, which is 100 grams. And I also have a change in temperature. Delta T, 70 minus 10, should be 60 degrees Celsius. So what I'm going to have to do to calculate the specific heat, I know that I'm going to divide both sides by 100 grams and 60 degrees Celsius. So when I do so, that cancels. So my CP, my specific heat, is going to be equal to 2,500 divided by the product of 100 times 60. And as I'm looking, how many sig figs do I have here? Well, I have 2 right here. So I am only going to have 2 sig figs. So when I come up with my value for a specific heat, it's going to be 0.42. And if I look at my label here, nothing cancels out there. But I know from my previous example that specific heat had that label. So there I am with my specific heat, 0.42 joules per gram times degrees Celsius. Once again, it's just an effort of plugging the numbers in to my equation. Let's look at now our third example, just a little bit of a different one. Okay, it's more like the first one. So go ahead and write that down, and then we'll work it. The specific heat of wood is 2.03 joules per gram times degrees Celsius. How much heat is needed to convert 550 grams of wood at negative 15 degrees Celsius to 10 degrees Celsius? So Q is equal to CP times M times delta T. We are trying to solve for Q, the energy. So I have the specific heat, 2.03 joules gram times degrees Celsius. I should have a mass. I do. 550 grams. And my delta T, my final minus initial, will give me 25 degrees Celsius, because I have that negative value in there. When I do my math, I come up with a value of 27912.5. I look, I see 3 sig figs on every one of those. So when I have 3 sig figs, I'm going to come up with 27,900 joules, 27.900 or 27.9 kilojoules, if I would convert it to kilojoules. And the final example I have is just a little bit different, because this one we are going to be calculating for the mass. Go ahead and copy that and we will work it. The example states that granite has a specific heat of 800 joules per gram times degrees Celsius. What mass of granite is needed to store 150,000 joules of heat if the temperature of the granite is to be increased by 15.5 degrees Celsius? So once again, I write down my equation. Q is equal to the specific heat times the mass times the change in temperature. I need to have 3 out of those 4. I'm calculating for the mass. So I take my 150,000 joules. I take my specific heat of 800. M is my unknown. I don't know my mass. And my temperature is increased by 15.5 degrees Celsius. So what I'm going to do for this one is I'm going to divide both sides by 800. And the 15.5. Oops, that's not a right label. Joules, grams times degrees Celsius. So when I cancel out my labels, I'm going to have a value in grams. So my mass in grams will be 150,000 joules divided by the product of 800 times 15.5. And I'm looking again at 2 significant figures. So with 2 sig figs, I am going to get 12 grams to be my final answer. Don't forget the video notes, enthalpy, that are up on the board.